My name is Dr. Akinshola. The experiment we are considering today is determination of the specific capacity of a metal block, a conductor. And we are going to consider it under two categories. The first category is without cooling correction, and the second one is with cooling correction. Now, for the first category, we need the following apparatus and materials. We need a calorimeter that has a stirrer inside. That's it in my hand. We also need a thermometer to determine temperature at each stage. We need a beaker to heat the conductor, as we can see here, and we need a Bunsen burner to provide heat energy. We also need a Ritter stand to hold the metal block to be suspended in the beaker for it to gain heat energy on the Bunsen burner. And we have to ensure that the metal block does not touch the base of the beaker. Then we also need a stop clock, a stopwatch, to also time the rise and fall in temperature when we get to that stage. These are the materials and the apparatus needed. Now, the procedure is this. The first thing is to weigh the metal block that we want to determine its specific capacity. You weigh the metal block and you record it as M meter or M1 in grams. Then the second thing is to measure the mass of the empty calorimeter by placing it on the digital weight balance like this, and you record the value in grams. Then you remove it, then you fill your, like I'm doing it, you fill your calorimeter with water 1/3 full. Then you place it again on the digital weight balance, as you can see. Then you record it, and you refer to that as M car plus water, or you can name it M3, and it's also in grams. Then you determine the temperature of the water in the calorimeter. That's the room temperature of the water when nothing has been transferred already, and take that as T1. Just put the thermometer in your calorimeter like this and refer to that as T1. Then the next thing is that you heat the metal block, like I said the other time, suspend it in water, and the precaution is ensure that it doesn't touch the base of the beaker, and it's suspended with the help of this Ritter stand, as we can see, and you allow the water to boil. It is generally believed that the boiling point of water is 100 degrees Celsius. So when the water boils, the temperature, you take it as T2. That's the boiling point of water, 100 degrees Celsius. Your T1 is also recorded in degrees Celsius. Then when the water boils, you still leave the metal block in it for it to gain heat very well, and leave it for about 5 minutes. Then after that, you quickly transfer it into the beaker that contains water at room temperature. When you transfer it there, then you start stirring, and your thermometer is also inserted. The water here has actually been at room temperature initially, so the transferred heated metal block in it will make the water to be gaining heat, and the temperature will start rising. This temperature will start rising. It will get to a point that it will no longer rise, and at that point, you take it as T3 in degrees Celsius, and that is all you need for the readings. Then you check the given manual for the needed mathematical expressions to determine the specific capacity of the metal block, known as S. That is for without cooling correction. Now, for the second category, which is with cooling correction, you introduce an ice into your water in the calorimeter, or a very cold water. You introduce it into the, definitely lower the temperature. So when you introduce the very cold water into it, it will have lowered the temperature. Then the next thing is you introduce your thermometer to measure the temperature fall at interval of 30 seconds. So at interval of 30 seconds, use your thermometer to determine the fall in temperature. To obtain a particular curve, you plot the temperature against time. Then after that, the heated object, you introduce it again into the water that is already cooled with your ice or your cold water. You introduce the heated object into it. Then you take another temperature rise at interval of 10 seconds. Take another temperature rise at interval of 10 seconds with your thermometer also, as you can see here. Then you plot your temperature against time also. Before you introduce the heated object, you have a curve. Then by the time you introduce the heated object and you time it at interval of 10 seconds, the temperature will start rising again from the calorimeter with your thermometer. You have another curve by plotting temperature against time. And this will give you the curve that is demonstrated to you, illustrated to you in the manual. Thank you.